Okay guys, today we're doing 5.5, speeding up and slowing down. So let's get started. Okay, first of all, let's talk about what does it mean to speed up or slow down, okay? So let's start with an easy example here. Let's say I'm on the freeway, okay? I'm going 60 miles per hour, and I change my speed to 80 miles per hour. Well, that is 8. Let's say I switch it from 60 to 80. That would definitely be considered speeding up, right? I sped up. Okay, let's say I'm going to give another easy example. I go from 60 miles per hour and then I go down to 40 miles per hour. Okay, well that would be slowing down, right? Okay, let's give a different example here. Let's start taking negative values. Let's say I'm in reverse and I'm going negative 5 miles per hour. And I begin to go negative 10 miles per hour. Okay, in order for me to do that, I hit the accelerator to speed up to a faster velocity backwards. So a faster speed, right? Because all I'm looking at is I am looking at this number right here. I'm basically looking at speed, I'm not looking at velocity. Right here, what I did was I sped up because I went from a 5 to a 10. Yeah, I went from negative 5 miles per hour to negative 10 miles per hour. So that means I sped up. But like, let's say I was going negative 5 miles per hour and I wanted to come to a stop, so I hit the brakes a little bit to come down to negative 2 miles per hour. My magnitude, or the number here, got smaller, right? So that would mean I slowed down. Okay, so what we're talking about in order to determine this is we're looking at the number. If the number gets larger, you speed up. Yeah, if the number gets smaller, that means you slowed down. Okay, so let's look at this on a graph. First of all, let's ask some questions about the graph just to get you guys acquainted with it. Okay, so this is a particle's velocity, and it's given by the graph below, okay? The y-axis represents velocity, the x-axis represents time. Find when the particle is moving to the left. Okay, well, we determined something's moving to the left if the velocity is negative, right? Well, that would be whenever it's below the x-axis from 1 to 4. That would be when the velocity is negative. So we can say it is moving to the left from 1 to 4 because velocity is negative, right? Okay. Find when the particle changes direction. Okay, so if you guys remember the last one we did, a particle changes direction when its velocity equals 0, and it switched from moving to the right to the left, or vice versa. So velocity equals 0 right here and right here, but did it switch from moving one way to the other way? So here it's moving to the right because it is positive, the velocity is positive. Here it's moving to the left because the velocity is negative, right? So that means it switched. It changed direction, yeah? So t equals 1 is a place where it changed direction. Let's see if this place over here, it's moving to the left, and then it switches to having positive values, so it's moving to the right. So at t equals 4 is also where it changed direction. And we can say that this is because the velocity changed signs. Yeah? Okay, now let's start talking about maybe what we're talking about here, speeding up and slowing down. So I'm going to get rid of this stuff. Let's go to another slide here. First thing, how would you look at acceleration on something like this? Okay, so this is a graph. We still have the same graph, okay? The y-axis tells us velocity, and the x-axis tells us time. So how would you look at acceleration on this graph? Well, if you remember what we were talking about the other day, the derivative of velocity is acceleration, right? So derivative means slope. So the slope of this graph is equal to acceleration, right? So that's how you would look at acceleration on here. So if it asks like when is acceleration negative, you would say that it's negative whenever it has a negative slope, which would be from 0 to, that's a 0, it kind of looks like a 6, from 0 to about 2.5. Yeah? If you were asking when is acceleration positive or when is it increasing, that would be from 2.5, and it looks like it goes like that until infinity. Okay? So is the particle, now we're going to talk about speeding up or slowing down. Is the particle speeding up or slowing down? And we're going to talk about 4 different time periods I have here. So let's first look at 0.5. So we're looking at this value right here. Okay, remember, we were saying speeding up means that the velocity or the speed is getting larger. Means that the number is getting larger. Yeah? Slowing down means that the number for velocity, the magnitude, is getting smaller. So at this point right here, it has a magnitude or a speed of about 2.25, somewhere around there. And what's going to happen is it's going to get smaller. It's going to approach 0. So right here you would say that this is slowing down. Okay? At 2, let's see what's happening at 2. Well, you have a velocity of, it looks like a magnitude. Now remember, I don't care about the sign. All I care about is the number, about 2.75, and it's going to continue to go to 3. So it looks like it's going to speed up because its acceleration is accelerating it. It's making it go faster. Okay, at 3, you have a velocity of about 2.75. Yeah, well, a speed of 2.75. It's a velocity of negative 2.75. And then we are approaching a velocity of 0. So that means that it's slowing down. Now, if none of this makes sense, I'm going to show you a really easy way to determine this right now, okay? Now, let's look at 4.5, the last one I got on here, and it has a velocity or a speed, they're both the same in this case, about 2.25, and it's going to get bigger. So that means that it's speeding up. Okay, so in order to determine this, let's look at what we were looking at. First, I looked at the velocity. I wanted to see what it was. And so in this case, I determined the velocity was positive. Okay. I think I accidentally clicked something on my pen. Give me 1 second here. Oh, well, it's giving me some problems. Okay, it's saying that the velocity, I'm saying the velocity is positive up here. Now, I'm also saying that the acceleration, the slope, remember the slope tells me acceleration. The acceleration, oh man, my pen's giving me all sorts of problems. The acceleration, I'm going to have to write it to the right of it, I think. Acceleration is negative because it was going down. It had a negative slope, right? So let's do that same thing for the rest of these and see if we see a trend here. At 2, the velocity was negative, and the acceleration, the slope, was also negative. Okay, at 3, the velocity was negative, and the acceleration, well, has a positive slope, so it's positive acceleration. Okay, the last one here, at 4.5, the velocity was positive, and the acceleration was positive. It had a positive slope. Okay, look at the trend here. Slowing down, it had a positive, negative. Slowing down, a negative, positive. On speeding up and speeding up, they were negative and negative, and positive, positive. So you can always use this. If it's ever asking you if something's speeding up or slowing down, all you need to do is check the velocity and the acceleration. If they are differing signs, that means it's slowing down. If they are the same sign, that means it's speeding up. And this makes sense, okay? Let me just explain it real quick if you're not getting it. This slowing down one, if you're going to the right and then you accelerate to the left, that means you're slowing down. So let's do this one right here. I'm traveling to the left and I accelerate to the left. that means I'm going to speed up. Okay, this one right here. I'm traveling to the left and I'm accelerating to the right. That means I'm going to slow down. Last one, I'm traveling to the right and I'm accelerating to the right. I'm going to speed up. So if they have the same sign, it's speeding up. If they have differing signs, it's slowing down. And you might want to write that down somewhere because that's important. If they have the same sign, it's speeding up. If they have differing signs, it's slowing down. So if you ever see the question, if it's speeding up or slowing down, you want to check the velocity and the acceleration at the point they give you. Okay? If it's the same sign, it's speeding up. If it's the opposite sign, it's slowing down. So let's just do this on one problem here. Okay, the formula gives position. Is the particle speeding up or slowing down at the given times? Okay, well, I'm going to check it at 2. Well, I need to, since it asks speeding up or slowing down, I need to check the velocity at 2, and I need to check the acceleration at 2. That's all I care about. They're the same sign, speeding up. So I'm not given velocity, so in order to get velocity, I'm going to take the derivative of this. It's going to be a 6x squared minus 6x, and that's it. And I just realized this was a mistake on my part. I used a t in here and I used x's in here. We are talking about times, so it's more correct to use t's. So let's switch these things to t's so it makes more sense here. Okay, so that's a formula to find velocity. Now the formula to find acceleration is going to be the derivative of that, which would be 12t minus 6. Okay, let's just check it here. 6 times 2 squared minus 6 times 2. Okay, well, I don't care what this gives me, but this number is going to be larger than that number. So that minus that is going to give me a positive number. I know it's traveling to the right. Let's check this. 12 times 2 minus 6. I don't know why I put a parentheses there. Okay, 12 times 2 minus 6, that's a positive number as well. So since they're the same sign, this is going to be speeding up. Okay, let's check it at 1. Okay, so I'm going to check my velocity at 1 and my acceleration at 1. So my velocity at 1, it's going to be 6 times 1 squared minus 6 times 1, and that's going to give me 0, right? And the acceleration at 1, 12 times 1 minus 6. Okay, that's going to give me a positive number. Okay, I threw this one on here because it's a little different, because I told you if they're the same sign, it's speeding up. If they're differing, it's slowing down. Well, this one doesn't have a sign. Well, think about something that's not moving, and then it continues to move. It begins to move. That would be speeding up. So it doesn't matter if this acceleration would have been positive or negative, because it would have went from not moving to moving. And when you go from not moving to moving, that means you're speeding up. So there you go. That should be everything here.